Ready? So, unlike the previous one, when you have this case of function, you are not going to have just vertical and horizontal asymptote. Okay? You're going to have the vertical, because the vertical is when the denominator is 0, so vertical will always exist. Rather than having horizontal, you're going to be having slants. Oh my god. What are these babies doing out here?
Leo, go ahead and skate one.
Okay, so basically, please pay attention, sir. Can I go back? Yes. So basically, this is one important aspect we need to always consider. If you want to graph or describe what the graph is, the first thing is to put it in this form. When you put it in this form, well, maybe not the first thing exactly, but to understand the nature of the graph, you have to be able to put it in this form. You know you have your vertical asymptote when this is equal to 0, which is the denominator. Okay? And rather than having the horizontal asymptote, as x becomes large, be it positive x or negative x, this denominator becomes 0. So, which means this fraction becomes, it vanishes, then you're left with this. Then this is the equation of the slant asymptote. It could be positive p, it could be negative p, depending on the nature of it. Okay? So, let's see, and that's called slant or oblique. Slant or oblique. It's not vertical, it's not horizontal. Okay? So let's go through with this example quickly. We have this function. Find the vertical asymptote. I think that is easy. Vertical asymptote is just x is equal to 2. Find the axis intercept. Of course, when x is equal to 0, what is y gives you the y-intercept. When y is equal to 0, what is x gives the x-intercept. Please, he's not listening. I hope you don't do something and waste my time later. When x is 0, that's f of 0, because the original function is called f of x. So f of 0 simply means when x is equal to 0, so this is your y-intercept. When the whole thing is equal to 0, which means when numerator is equal to 0, you get the 2x-intercept. So we have that at the back of our mind. On y-axis it crosses once, on x-axis it crosses twice. Okay? Now, having said that, we now want to get the equation of the oblique asymptote. And that's why you need to use the division algorithm. Okay? And once you do that, you can express it in this form. Okay? And this is the equation of the oblique asymptote. I prefer you do your workings here before you write the result. I don't want to write in the results and put the workings on the side, please. So, the sign diagram is another important aspect. Now, we have two vertical asymptotes just like the other one. Okay, you put the asymptote here, and you put the intercept as well. You can see the intercept. No, this is the asymptote, just one, right? Sorry. One asymptote, two intercept. Intercept are thick lines, asymptote is dotted line, just like the other cases as well. So the only difference here is you're having an oblique asymptote. That's the major difference. Every other thing is exactly what you've been doing. Then you consider what happens as x moves towards the asymptote on both sides. And as you can see, because we have only one asymptote, rather than having six behavior, just like yesterday, we only have 4, right? So only the asymptote from left to right. So if you can look at it, as x approaches -2 from below, and from this side, that's positive. That's why you have positive infinity. Okay? You don't consider it, you consider this one, right? Hello, everybody get what I mean? Okay, when it approaches from above, so you have a negative there. Then you consider what happens at the extremes. So when x goes to the extreme here, it's always positive. Where is it? When x goes to the extreme here, this approaches 0 from the positive. And what happens? This f of x approaches that asymptote from above. Do you understand that? Again, when x approaches, okay, it's this one now. This one is this one. When x approaches infinity from this side. Okay? When x approaches infinity from this side, remember, you already have it in this form. This becomes 0 from above. Why is it from above? x approaches negative infinity. So take this as negative. Minus minus is plus. Am I making sense? So that's why it's approaching it from above, because it's plus now. So this is the one that vanishes. Remember, normally, if this was a number, you will say, oh, this approaches that number, right? But this time around, it approaches the function, which is a straight line in slant form. Okay? And similarly, when x approaches infinity from the positive side, if that becomes positive, and this is negative, then everything here approaches 0 from negative side. Does that make sense? And that is why you have this. And of course, if this fraction vanishes, it's going to be approaching the line also from below. Okay? So, and that's what led to this. So let's try to understand E and this shape. So the first thing I would do, draw this and draw the line. Okay? Then take note of your intercept. We have one intercept here and we have two intercepts here. Now because it shouldn't cross this line, right? Then you know one part is within this area, one part is within this area. Then you look at the behavior. When x approaches negative 2 from below, where's negative 2? This. Negative 2 from below, which is from here to here. What does the function approach? It approaches infinity. So from here to here, the function is going up. Okay? When x approaches negative 2 from above, which is coming to this side, which means from here to here, sort of, right? From here to here, something like that. Okay? What happens? It approaches negative infinity. So when this guy is coming here, the function is going down. Remember, it's just going to be looking at this and not really touching it. And the last part, now you have only constructed from here to here, you have constructed from here to here. You haven't done this part. That's what the last part is useful for. When x becomes large on this side, which is what happens from here, because I've constructed it, but I haven't constructed this. What happens is going to be approaching this function, okay, from above. Where is this function?
You look at
Oh yeah, I look at the wrong one, sorry. Okay, from below there, something like this, okay? It's approaching it from below, so it's from here. From below doesn't mean you start from here again. It means you are starting from down going up. So you just continue and make sure it doesn't touch it. So you just extend this line, make sure it doesn't touch it. And the last part, which is the one I was looking at before, so when x approaches, when x goes this direction, it's going to be approaching this line from above this time. So this will continue and it's going to be moving close to the line from above, something like that. Now, this is one part. There's a reason we have this shape. I will ask you towards the end of the class and I'll show you something that might be responsible for it. But I'm thinking we should do one together. Let's look at maybe question 1. Let's see. Here's the example again. That example gives, okay. Can you change question 1 to mixed fraction form? 1a, change it to mixed fraction. Or better still, wait. I'm thinking, can somebody quickly do the division algorithm and tell me what you have for 1a? I want to be sure that that is the one that gives me what I want.
180.
Yeah, 1a. Just do the division algorithm and tell me the equation plus or minus that. That's what I want to know.
That's 2A.
2a, sorry. You know what I'm talking about. 2a, quickly. Let's take one together. I want to be sure it's not in this form. Are you done? Where's your remainder? What is your remainder? That's what I want to know. Remainder is minus 6? Minus 6? Minus 4? Okay, then try number then that's not the one I want. Try number C. Could you try C? I want the one with the positive remainder. Actually, we can use remainder theorem. When x is equal to 3, do we get... Yeah, this should give you a positive remainder. Give you a positive remainder? Okay, so let's do this. Let's do this. Okay, so for the function, I hope that's not part of the worksheet anyway, because I picked some of them in the worksheet. Oh no, is it this one?
Yes, see.
Yeah. Okay, yeah, we just did together. That's okay. So let's do C together. Of course, if you look at your book, you can always do more on your own. So for the first one, 2C. The equation, the function is defined as 2x squared minus 8x plus 8 divided by x minus 3. So the first question is find the equation of the vertical asymptote. The vertical asymptote is when this is equal to 0. Yeah? So x equals to 3 is the vertical asymptote. Okay? Find the equation, find the intercept, okay? For the intercept, when x is equal to 0, y will be 2, 0, minus 0. It doesn't matter. I'm just going to say 8 over minus 3. Is that okay? So that's just negative 8 over 3. When y itself is equal to 0, the original function 2x squared minus 8x plus 8 divided by x minus 3 is equal to 0, and this is only when the numerator is equal to 0, which means 2x squared minus 8x plus 8 is equal to 0. What are the factors? Oh, I can divide by 2 first. If you divide by 2, you get x squared minus 4x plus 4. Oh, great. You have equal roots, 2 and 2. Uh-oh, so we only have one intercept, basically. All right. So x is equal to 2 is the intercept. Then, that's the x-intercept, this is the y-intercept. Oblique asymptote. Oblique asymptote. To get that, we split it into 2. So, let's do the division algorithm. X minus 3, 2x squared minus 8x plus 8. The first gives 2x, 2x squared minus 6x, negative 2x. Please check if I'm right or wrong. Minus 2, yes? Then we have minus 2x plus 6, then we have plus 2, yes? So that gives y is 2x minus 2 plus 2 over, you missed that, sir. Oh, you did not. So far, are you know the Flash characters in the movie Flash? Okay, so let's discuss the sign diagram. So we have one vertical asymptote, x is equal to 3. Then we have only one intercept. We don't have two intercepts. X is equal to 2. Okay, so what do we have? So let's consider the asymptote will be broken line. The intercept we have used a thick line. So we have 3 regions which you consider here. So for the first one, this one, let's pick 1 for example. When you put 1 here, this is negative below. Above, this is plus 8, no, 2, minus 8 plus 8, this is 0, that's 2. That's negative. Do you agree? So if this is negative, this is positive, and this is negative. Okay? You can check. When you put 4, this will be 16, 32. 32, 8 times 4, another 32. So that's positive, right? Then this is positive. Wait.
What? You can take the x equals 0.
Where's 0?
Like when x equals
0 is here. Oh, okay. Yeah, 0 is here. We've checked that. I'm trying to check the one above it. So let's check 4 again. 8 times 4 is 32, right? 4 squared is 16. 2 times that is 32. So that's positive, right? And this is what? That's positive also?
Yeah.
So that's positive. Then I'm not getting the alternating. I'm not getting the alternating. What's going on?
Let's use technology.
What? What is it? Let's try 2.5. Perhaps because of this equal root thing. That's why we're having.
Yeah, because equal root, the two next to each other are equal.
Yeah, but then if it was here, the alternating will work. So why are we having?
No. The one in the middle is negative.
What do you mean?
Like it's negative, and then positive.
Negative, negative, positive.
Yeah.
Okay, so because
the two is the equal root, right?
okay, check 2.5. What is the sign between 2 and 2.5? It's negative. Okay. So I guess because of the equal roots, that 1 plus is kind of absurd. That's weird. Anyway, and this is positive. Okay, great.
Yeah.
Everybody clarify that? Yes?
Yeah.
No, don't wait. If you do that first, you're not going to learn from mistakes. I could have just shown the solution also, but I want us to do it together. Let's see why this is this, why this is that. Alright, so that should be your last result. I said that yesterday. Okay, so quickly, let's look at the behavior. As x, there is only one, right? Which is what? 3. X tends to 3 from above, x tends to 3 from below. Then x tends to infinity from above, or positive infinity, actually. There's nothing like above. X tends to negative infinity. So what happens to y? When x tends to positive 3 from above, okay, what happens? Is the graph positive? Yes. So y tends to positive infinity. What about from below? Then that's negative. Hello? Yes? And when x becomes so big on the positive side, y tends to, now, so you consider here, this part tends to 0, okay? So not y now. This part, 2 divided by x minus 3 tends to what? 0 from positive or negative? From above or below? Positive. From above. So this is positive infinity, right? And there's no negative here. So that's 0 from above. Okay? And consequently, y now tends to, what is that equation? 2x minus 2 from above. Of course, the sign here and the sign here must be consistent. Okay? And for negative infinity, when x becomes so large on the negative side, this fraction tends to 0 from below. Do you agree? Which means y tends to 2x minus 2 also from below. Okay? So with this, we can try our best to have a sketch. So, your xy plane. Let's take care of the intersect. Vertical asymptote is x is equal to 3. Another x is equal to 2 is needed. So x is 1, 2, 3, something like that. Okay? So we have a vertical asymptote, x is equal to 3. Now, this is one intercept. Will you have a y-intercept?
Yes.
Negative 8 over 3. So 8 over 3 is like 2 point something, right? So maybe something here. Okay, so I put the dot there. So what else do we know? The equation of the line is 2x minus 2, right? So the gradient is positive, is here, and it's cutting at the negative side, which is minus 2. Now this is 2 point something. So it means the line will pass through a region above it. Do you agree? Because negative 2 before you get to 2 point something, right? So the line passes through here. And what is the x-intercept of that line? X-intercept of this line will be 1. I'm just trying to get a good sketch. When y is equal to 0, x is 1, right? So the line will pass through negative. I don't know. Do you get what I'm saying? What's my bag? Do you understand what I mean by x-intercept, y-intercept, and what is necessary? Leo, do you understand? Then don't keep quiet. What's your problem? I'm asking a question you don't understand, and you're just quiet, waiting for me to call your name. Really? I don't have time. That's why I'm rushing this stuff. And if you don't understand, it's just a waste of my time as well. Do you understand this so far?
Not the last one.
This one.
Yeah.
This is the intercept of the curve. We have gotten that. The axis intercept of the curve is y equals this and x equals 2. So x equals 2 is this. The curve passes through that. Then y equals negative 8 over 3. And I say negative 8 over 3 is negative 2, 1 over 3, which means 2 is above it. Understood? Now, why is this 2 important? This is negative 2. Why is this negative 2 important? This is the equation of the oblique asymptote. We didn't even do that. Which one is this? That's 4. So 3 is here. So we should have written that. That equation of oblique asymptote, okay, is what? Y equals 2x minus 2, which is this part. Does that make sense? Ha. So now 2x minus 2 means it's going to intersect the y-axis at minus 2. That's why I took note of the minus 2, because you have to be careful. Is the line cutting it above this intersect of the curve or below it? You have to be very careful with that. Okay, so we pick that. Then it will be nice if we can know the x-intercept as well. X-intercept of this line is when y is equal to 0. And that means x is equal to 1. So our x is equal to 1 will be somewhere here. Do you agree? Then we can draw the straight line as this. I don't have a ruler, so please don't make fun of my line. So it's going to be a straight line. Uh-oh, it bends, right? The last air bender. Well, you will draw a perfect one with your ruler, and of course make sure it's a broken line. So something like that. Okay? So this is 1. It passes through 1, and it passes through negative 2. That's what we know. Probably need to write this elsewhere, because I can see something already. Right? So, this continues. Something like that. Okay? So now let's see what we can sketch. So everybody please listen. As x tends to, so clearly this curve is going to pass through negative 8 over 3. The curve we are about to draw will pass through here, and we pass through here. So I put that in blue because I'm going to draw it in blue. So we know where it must pass through. And it's not going to touch this, it's not going to touch this line. Okay? It looks like a curve, but it's okay. When x approaches 3, this is 3. Okay? The only vertical asymptote. When x approaches 3 from above, when x comes here, this y approaches infinity. So the line goes up. But then there is no way it could go up if it has crossed this line. So it must go up after this line. Do you get my point? As x comes close to 3, this line continues to go up. So it doesn't make sense for me to draw this because it's already crossed it, right? So which means this part does not exist. So I'm having something like this. Let's just wait. Okay? Now let's look at when it approaches it from this side, especially between here and here. Now the line passes through here. So let's say from here now, what happens? The line goes down. So from here, it goes down. So okay, it passes through here. Okay, let's wait and see what happens next. Then what do we know? When x becomes so big on this side, this line approaches this curve from above. When x goes infinity, it approaches this from above. So it's coming from above, approaching the line, sort of. So it's of this form. Okay? And I'm sure that's what you saw in your sketch as well. Then, when it's going this way, it's approaching this line from below. So it's coming down from below. So from below, it's approaching this line. So if it comes up, then it's going to go back here. Okay? But it's going to cut this, right? But I don't know if it's going to go in here or not. Because no, it's going to have to touch. Remember, it's going to have to touch. Because if it goes in and comes out, then you have 2 intercept. But unfortunately for us, we only have 1 intercept. So it's just going to touch here and come back. Am I making sense? If there are 2 intercepts, it will go this way and come back this way. Then you have 2 intercepts. Only 1 intercept. You're just going to go that way and continue to try to touch that line. I think that's what we'll have. Is that what you saw when you put it online? Okay, so let's see what we have online. Let's see ourselves. Ask your question means 2 divided. Everybody please listen. 2x squared, right? What's the equation? Minus 8x, plus 8 divided. Okay, so let's see. Is that what we have? Then we have x, 2x minus 2. Can you see? Then that's what we have. Okay? Now, I ask you something. I'll show you in the book. It was a question in the book also. Any curve you sketch with this equation, these are the 2 possible shapes you can get. Of course, they could flip. Because if the gradient of the line is negative, it will flip. If the gradient of the line is negative here, it will flip. Oh, wow. Did you miss it?
No. It's good.
Okay, wait, that's me. Okay. So we have 2 flashing men in the class. Thank you. I need to do something. Maybe what I would do is I play music underground so it doesn't go off, you know. I can. Admin password or something. I'll check because there are some things we can't do on the school computer. You all know that. Okay, so can you think of what is different? This and the example in the book that makes the shape this way. Look at the example in the book. I know I will have to tell you this today, but I want you to look at it. Look at the example in the book. Okay, the question is here. Look at the shape. Compared to the example that we did, and look at the shape, can you think of what could lead to this form or this form? The remainder. That's why I didn't want to mention remainder at first because I know I was selling myself out. If the remainder is positive, I discovered that this is what you get. And if the remainder is negative, then you are bound to get this. So let's take note of that. That will help us a lot in our sketching. If anybody sees something otherwise, please let me know. But that's the observation I've made so far. Because I look at that, I was going to give you, but then we have to drag this over and over again, and I don't want us to drag it too much. But you can always do that on your own. Okay? So please